Today we're covering how to scrape vehicle VIN history and specifications data. Every vehicle manufacturer for sale has a unique vehicle identification number, a 17-character code that unlocks a wealth of information about that specific car. VIN data includes manufacturing details, specifications, ownership history, accident records, service history, and recall information. For automotive businesses, accessing this data at scale is essential for vehicle valuation, fraud detection, risk assessment, and market analysis. This guide covers how to extract VIN-related data from various sources using proxy infrastructure, including VIN decoding, history report extraction, and specification database building. A standard 17-character VIN encodes specific information in each position. Positions 1 through 3 form the word manufacturer identifier, which identifies the manufacturer and country of origin. Positions 4 through 8 make up the vehicle descriptor section, describing the vehicle type, body style, engine, and transmission. Position 9 is a check digit for mathematical validation. Position 10 encodes the model year. Position 11 identifies the assembly plant, and positions 12 to 17 are the sequential production number. For Southeast Asian markets, VIN structures may vary slightly depending on whether the vehicle was manufactured locally or imported. The Archipelago CHE or Spatial weathers after vacations. The NHTSA VIN Decoder API is a free official US government API that decodes North American VINs. Some manufacturers provide VIN lookup tools directly on their websites, and commercial third-party decoders offer comprehensive VIN decoding for a broader range of vehicles. Vehicle history services aggregate accident history, service records, and ownership changes. Carfax and AutoCheck both cover North America with different data partnerships. SG CarMart VinCheck handles Singapore-specific vehicle history, and Postparcom covers Malaysian vehicle inspection records. Hardback registration data varies by country. In Singapore, the LTA maintains vehicle registration and deregistration records. In Malaysia, JPJ holds road tax and registration information. In Thailand, the Department of Land Transport manages vehicle registration data. The NHTSA VIN decoder is free and does not require proxies for moderate use, but high-volume decoding benefits from proxy rotation to avoid rate limits. The API supports batch decoding of up to 50 VINs per call, making it efficient for large datasets. Vehicle history services require proxies due to their aggressive anti-bot measures. Each request should appear to come from a legitimate residential or mobile IP, with session continuity maintained throughout the lookup process. For Singapore-specific VIN and vehicle data from sources like the LTA or SG CarMart, Singapore-based proxies are required to access region-restricted databases and avoid triggering geographic blocks. A data collection pipeline gathers VIN data from multiple sources, normalizes the fields, and stores results in a structured database. The schema typically includes tables for vehicle identifiers, decoded specifications, history records, and regional registration data, allowing cross-referencing across sources. VIN decoded specifications support accurate vehicle valuations by providing verified data on make, model, trim level, engine, mileage, and accident history, which feeds directly into pricing models. VIN data helps detect common types of automotive fraud, such as odometer rollback, title washing, and cloned VINs by cross-referencing history records against registration data. Aggregating VIN data lets you understand market composition, track fleet age, identify popular configurations, and monitor regional demand trends. VIN databases and history services have strict rate limits. Batch NHTSA requests using up to 50 VINs per call, space requests 2 to 5 seconds apart for other services, use data research tools, mobile proxies for services that detect and block data center IPs, and implement exponential backoff on rate limit responses. Use US proxies for NHTSA and North American VIN services, Singapore proxies for LTA and SG CarMart, and Malaysian proxies for JPJ and Malaysian dealer sites. Data research tools provides the geographic coverage needed for multi-region VIN data collection. On Rovers, therefore, use sticky sessions from data research tools to maintain a consistent IP throughout the session, rotate sessions between different VIN lookups, and clear cookies between sessions to avoid tracking. VIN data is the backbone of automotive intelligence. From basic specification decoding to comprehensive vehicle history extraction, the ability to collect and analyze VIN data at scale powers valuations, fraud detection, and market research across the automotive industry. Data research tools provides the proxy infrastructure needed to access VIN data sources reliably, with mobile proxies covering both North American and Southeast Asian markets, geographic targeting for region-specific databases, and the throughput to handle high-volume VIN processing. Whether you are building a vehicle history tool, validating dealer inventory, or analyzing market composition, reliable proxy access to VIN databases is a fundamental requirement. For further reading, check out our guides on automotive inventory tracking across multiple dealer websites, automotive review aggregation using proxy networks, scraping AliExpress product data without getting blocked, Amazon buy box monitoring with proxy setup, how anti-bot systems like Cloudflare, Akamai, and Perimeter X detect scrapers on API versus web scraping with a focus on when you need proxies and when you don't. That wraps up today's deep dive into scraping vehicle VIN history and specifications data. Head over to our website at dataresearchtools.com for more guides and tutorials covering proxies, web scraping, and beyond. Thanks for listening, and I'll catch you in the next one.